Hello everyone, my name is Sathiyah. So in this video presentation, I will be presenting about my final year project 2, which is entitled of Wear Performance Investigation on Aluminum-Based Metal Matrix Composite prepared through THIXOFORMING. My supervisor for this project is Mr. Amar bin Abdul Rahman, and I will be presenting all the slide contents one after another in the following slides. As for the first segment, let's get into this introduction. As for the introduction, I'm about to answer a question, which is what the project is mainly about. The project is mainly about focusing into the modification and also enhancements that can be made through by reinforcing a CNT within an aluminium A356. By reinforcing aluminium with CNT, the composition can make a metal matrix composite, and the metal matrix composite is widely applicable in a wide range of industries due to the fact of it having a lightweight and also high strength of mechanical properties. So the project that I'm right now conducting is aluminium is used as the matrix, and also CNT is used as a reinforcement. Aluminium here is act as a matrix just because it has a high damping ratio, and also it is very applicable for the use of lightweight. And also CNT, it has a very unique strength of dispersibility and also cost effective for the reinforcement material. So from that, we also implemented the THIXOFORMING technique for the material characterization, and also like improvising method for the process that we used here is THIXOFORMING. So THIXOFORMING generally helps to improvise the mechanical properties and also like the microstructure of the aluminium. So hereby we also use the T5 heat treatment in order to improvise and also enhance the microstructure of the aluminium. So from that, the testing that I'm going to conduct and also conducted in this project is wear performance analysis. In general terms, aluminum is very soft, and also couldn't resist for the excessive resistance. But then by reinforcing with CNT, we are going to test about how the CNT resistivity influences and also enhances the aluminum together with the strength. Moving on to the next part, which is problem statement. Let's be look into the problems that involved in this project development. For the first problem, it's mainly about the steering effect. The steering effect was not widely investigated. And for the second one is about forecasting the wear performance. The wear performance forecasting is really challenging. And the third one is going to be the impact of CNT and also steering was not comprehensively studied. And the final one, fourth problem is very limited resources are available on the impact of T5 heat treatment, and also the microstructure as well as wear performance was investigated. Moving on to the next part, which is objective. There are four objectives available for this project. The first one is to develop the optimized feedstock parameter by using DOE Technology method, and the second one is to study on the wear performance of aluminum reinforced CNT matrix. And the third one is going to be about to characterize the CNT content and also steering effect in terms of wear performance. And the fourth one is to highlight and also to outline the T5 heat treatment's benefit and also effect. Moving on to the next part, which is scope. As for this research, there are three main scopes that we are focusing in. The first one is to produce globular microstructure by using THIXOFORMING. The second one is to characterize the microstructure evolution by using SEM and also XRD techniques. And the third one is to use the Naberthum furnace for T5 heat treatment and also micropod turbo tester for the wear performance. Moving on to the next part, which is methodology. As for the process methodology, we can say that the process was exactly run in order as how the flowchart displayed in the screen. For the first step, there was the material selection, which the aluminum A356 is set as the metal matrix, and also the multi-wall CNT is used as a reinforcement here. From that stage, we can actually proceed to the design of experiment, where the Taguchi method is used in order to get the entire run order of the experiment. And from that, we can actually proceed to execute the project, where by mixing CNT and also aluminum, we can get the AMMC. So the AMMC is mainly about the mixture of aluminum and also CNT. So to ensure the uniform dispersibility of CNT, we can actually we use the mechanical stirrer here, and from that, once the molten metal is prepared, we can actually proceed to the permanent mold die casting method, where the molten metal is poured into the permanent die in order to get a cylindrical shaped specimen billet. So the specimen is then carried forward to the THIXOFORMING technique, and hereafter the THIXOFORMING technique, we send the specimen of microstructure and also wear performance in order to characterize the microstructure evolution, and also like to characterize the wear performance as well before the heat treatment. So once after the THIXOFORMING is done, the specimen is again carried forward to the T5 heat treatment in order to strengthen the material and also like to improvise the quality. From the heat treatment, the after the heat treatment samples are also sent to the laboratory in order to characterize the wear performance as well as to evaluate the microstructure evolution. So the process actually ends with by comparing the before and after of specimens results that obtained in this research. So as we can see that the second step would be the sample preparation for the casting method. The sequence shows that the aluminium and also CNT was mixed by the name of casting method. So for that, the magnesium and also CNT, which is magnesium is the wetting agent, CNT is the reinforcement, was pre-mixed in aluminium foil and also rolled up in order to ease up the mixing process later. And after that, the rolled aluminium was mixed with the molten metal which was previously molted using the 700 degrees Celsius. So the previously molted aluminium was then mixed with the reinforcement material, and straight away it was stirred using the mechanical stirrer for the allocated time of 10 and 15 minutes. So after the stirring was done, the molten metal is straight away poured into the permanent mold casting, and also the cylindrical shaped billets are then produced, and the produced samples are then carried forward to the microstructure investigation. For the microstructure investigation, there are two different techniques, which is SEM and also XRD. For the SEM, we are about to cut the samples into the small pieces by using diamond cutter, and after that the samples are being polished and then mounted by using rubber, and also after the mounting it was actually polished, then given to the SEM laboratories for the microstructure characterization. Then while looking into the XRD method, the samples was first cleaned, and also like they were also using sonidification method in order to remove the dirts within the samples. After the samples were cleaned, they were straight away sent to the XRD, and after that the evaluation was done, and we can obtain the graph from the laboratories. So this was how the microstructure investigation and also the sample preparation for the casting was done. For the heat treatment is the fourth step, and the heat treatment was done by in terms of T5 heat treatment using number therm furnace that is available in the FKP laboratory, using 200 degrees Celsius up to 4 hours for the each specimen, and the specimen was located and also artificially aged for approximately 3 hours after the heating was done, and the specimen was collected later. And after the heat treatment, we are supposed to do the THIXOFORMING first. So the THIXOFORMING was done using a 110 centimeter of specimens. So the specimens was first heated up to semi-solid stage, and then was ramped using a hydraulic rammer with an approximate pressure or load of 10 kilonewton. So from that, the specimen was ramped and also reduced in shape. The ramped and compact specimen was then sent again for microstructure and also like to evaluate the wear performance in order to characterize the and also to justify the quality enhancements in terms of quality. And the testing was done here is wear testing. The specimen was attached to the micropod tribo tester, and the specimen was actually set towards a rotary type of wear testing, where the pin on this technique is used. The RPM set for this testing is 200 RPM, and also the load for this testing was 10 Newton, and the specimen was set about 30 minutes to be run in this wear testing, and also the data was extracted from the computer available in this FKP laboratory. Moving on to the next part, which is results. The below presented results are from scanning electron microscope, which is SEM. So as we all can see that there are two samples, which is sample A and B, and there are three categories to analyze, which is S-cast, THIXOFORMING, and T5 heat treated. So for the S-cast, we can compare that A and B are similarly having dendritic structures, but the A dendritic structures are clearly visible. And for the THIXOFORMING samples, we can say that both are having rosette, which is evolved from the dendritic structure, and the thixoformed samples are also showing that sample A as having a very clear rosette structures, which is nearly spherical shapes found in approaching globular structure. And after that, for the third segment, we can say that T5 heat treated samples are having globular microstructures, and the globular microstructures are mostly evolved from rosette microstructure, which is from the stage of thixoform. So sample A is in all categories are showing a very clear structures of microstructures. So in this aspect, it is more likely to be prepared, and also the composition was approximately mixed and also blended together. Then for the result and discussion, while looking into the XRD, which is X-ray diffraction analysis, we can say that sample A and B having a same composition, where 0.1 weight percentage of CNT and also 0.5 weight percentage of magnesium. While the difference here is the stirring time. For sample A, it is about 10 minutes was stirred, and also like sample B, the sample was stirred about 15 minutes. So the composition of XRD shows that sample A has a very optimal and like a very a stabilized graph of carbon, while sample B has a very high peak of carbon and also like inconsistent within the peaks of graph, showing that carbon has diffused. So A can be a very good resistive towards wear and also like mechanical properties, while B should have some other flaws and also like unpredicted failures can be occurred due to the unstable XRD flow of peaks. As in this part, the results were presented from the wear performance analysis, which is a wear test using micropart tribotester. So the first aspect here to analyze is mass loss. We can say that both sample A and B having a reduction in mass loss, but it is very obvious that comparatively A and B, A has a very consistent rate of mass loss, while B having a very descending and like a very sharp loss of mass loss within them, so that we can conclude that hay having a very good resistivity in terms of wear performance, and also like it is like more reliable. As for the second aspect of analysis in wear, we can say that the wear rate shows that it is very obvious A and B having a reduction, but comparatively A have a very consistent reduction, while B is having somewhere like the wear rate reduction is very high in B. Even though the composition of both samples are same, the steering type effects that the hay could be a very good resistive towards wear rate, and also it is more reliable. So as for this part of result and discussion, we are going to discuss about the coefficient of friction, which is COF. So for the sample A and B, we can obviously see that they both are not really in phase, where A and B are having two different phases. A is reducing while B is increasing. So the A value shows that the coefficient of friction for sample A is in reduction, while B is increasing, even though the compositions are same. So we can conclude that the A sample is a very good resistive towards friction, because the values are decreasing by each stage from S-cast to thixoform to T5 heat treatment, while B samples coefficient of friction, the index is slightly high at the third part, where the T5 heat treated samples are having 0.8, which is nearly going to be 1 of coefficient of friction. That is not really recommended. So for the next part of result and discussion, we can say that one surface analysis is one to show. For here, we can obviously see that for the sample A, there is a very less damage compared to sample B. In terms of comparing the S-cast and thixoform samples, the one surface of sample A is very less damaged, and the frictional force is also low, as I shown before, while sample B is having more damaged, and the damage are clearly visible. So we can conclude that Sample A is more recommended and preferably can use in more heavy duty industries. Moving on to the next part, which is conclusion and recommendation. So, as in conclusion, we can conclude that to eliminate the dendritic microstructure, we can implement the THIXOFORMING technique, and also through the T5 heat treatment, it was then transformed to be a globular microstructure. So, we can say that casting could be a very good technique to transform dendritic structures to become as a near spherical structure, which is a rosette. And also the third point would be like THIXOFORMING resolve issues like porosity, and also the wear performance also being increased and also enhanced in terms of mass loss, wear rate, and also coefficient of friction. So it will be resulting in a very better wear performance as a conclusion. After that, heat treatment also will be improving the mechanical properties, as well as it also like improve the overall strength and quality of a material. And also steering time will also be a very big influential character, or aspect to consider, because it has a higher effect on both qualities and of the composites. So in the aspect of recommendation, I would recommend to use the ball mill technique because it is like a very generated numerous issues of process handling. So ball milling technique would ensure them to be not repeatedly occurs, and to reduce the THIXOFORMING die cast size in order to reduce the waste of materials that has been generated through several processes. So by reducing the THIXOFORMING die size, it would actually reduce the material waste too. So that is all from me. Thank you for listening with patience.